Welcome back, mathematicians. In this video, we are going to look at reference angles. We're going to let theta be any angle that lies in a quadrant. The acute angle formed by the terminal side of theta and the x-axis is called the reference angle for theta. So first of all, because of the fact that these terminal sides lie in a quadrant, it means we're not looking at terminal sides lying on an axis, so no quadrantal angles. Also, I'm going to look at three cases here, or three examples. And so the first, no cases. One more time. Welcome back, mathematicians. In this video, we are going to look at reference angles. We're going to let theta be any angle that lies in a quadrant. So right there, that statement means that we're not looking at angles where our terminal side lies on an axis. So no quadrantal angles. The acute angle formed by the terminal side of angle theta and the x-axis is called the reference angle for theta. So notice what it doesn't say. It says the x-axis, never the y-axis. Also, it doesn't say the positive x-axis or the negative x-axis. It's just referencing the x-axis. It's also talking about the fact that this angle is always acute, so that means less than 90 degrees. So let's look at three cases. And case number one would be if the terminal side is in quadrant number 2. Now for all three of these cases, I'm assuming that we have counterclockwise rotation. So in quadrant number 2, here's my angle theta. So how would we calculate the reference angle? Well, first let's identify where the reference angle would be in this picture. And the reference angle must be this angle right here that I've marked in green, because that is the only angle that you can form with the x-axis and the terminal side. If you try to form this angle with the positive x-axis, you're going to get an angle that is larger than 90 degrees. So in other words, not an acute angle. So how do we get that angle? Well, you're going to take 180 degrees, which is the entire angle from the positive x-axis to the negative x-axis, and you're going to subtract from it the angle theta. Or in terms of radians, that would be pi minus theta. Now the second example is, what if the terminal side lies in quadrant number 3? That means this is the angle theta, and the reference angle is going to be this angle right here. One more time, it has to be the negative x-axis, because if you try to form it with the terminal side and the positive x-axis, you're always going to get an angle that's larger than 90 degrees. So how do we calculate that angle? Let's take the full angle of theta and let's subtract from it this angle of 180 degrees from the positive x-axis to the negative x-axis, and that will give you the reference angle. Or in terms of radians, that would be theta minus pi. Last case, what if the terminal side is in quadrant number 4? And so that assumes this rotation here, counterclockwise, all the way around to quadrant number 4. So in this case, the reference angle is the angle made up of the terminal side and the positive x-axis. So if you chose the negative x-axis, again, it would be larger than 90 degrees. So to calculate this, we are going to take one full revolution, which is 360 degrees, and subtract from it angle theta. Or in radians, that would be 2 pi minus theta. Now for all three of these cases, I did assume that we are rotating counterclockwise. The calculation would change a little bit if you're rotating clockwise with a negative angle. But your picture should look the same, where you are looking for an acute angle made up of the nearest x-axis and the terminal side. Now let's look at some examples where we are being asked to calculate the reference angle for each of the following. So first, 150 degrees. 150 degrees would have a terminal side in quadrant number 2. And with counterclockwise rotation, this would be our angle in the coordinate plane. What we're looking for is the reference angle. And the reference angle is going to be the angle made up of the terminal side and the negative x-axis. So to calculate that, we're going to take the whole angle, meaning 150 degrees and the reference angle. That would be 180 degrees. And we're going to subtract from it the part we don't want, which is the 150 degrees, leaving us with a difference of 30 degrees. And that would be your reference angle. Now what you'll notice with these is that there is no negative reference angle because we don't have rotation. We don't have an initial side on the positive x-axis. So for problem number 2, we have our terminal side in quadrant number 4. The rotation here is clockwise. And so the reference angle is actually the exact same angle because it's the made up of the terminal side and the nearest x-axis, which happens to be the positive x-axis. This means that the reference angle is just 45 degrees, no negative included, because again, there's no rotation. Let's now go to the next one where we have negative 11 pi over 12. So once again, we have counterclockwise or clockwise rotation rather. And this would put the terminal side in quadrant number 3. So here is negative 11 pi over 12 with the clockwise rotation. Our reference angle is made up of the terminal side and the nearest x-axis, which happens to be the negative x-axis. So again, since our reference angle is not in terms of a negative angle, what we can do is take this whole angle here, ignoring rotation, which is 180 degrees or pi, and subtract from it the part we don't want, which is the 11 pi over 12. Leaving us a difference of pi over 12. So that would be your reference angle. Again, it wouldn't be negative because there is no rotation. The last problem is 7 pi over 6. So 7 pi over 6 also is in quadrant number 3, but this time we have counterclockwise rotation. So to find this reference angle, which is made up of the terminal side and the negative x-axis, we are going to take the 7 pi over 6 angle, and we're going to subtract from it the part we don't want. And the part we don't want is the 180 degrees, or pi. And so when we subtract that, the difference will be pi over 6. All right, guys, good luck.